Correlation is the degree to which two or more events are related. For correlated events, the occurrence of one event is an indication that the other event is also likely to occur, that would be positive correlation or dependence, or likely not to occur, which would be negative correlation or dependence. Correlation can be quantitatively accounted for in the risk analysis using correlation matrices, or more qualitatively accounted for by applying expert judgment to the estimated probabilities associated with the responses of groups of similar components. In dam and levee risk analysis, what needs to be correlated? The probability of loadings that define a hazard curve should be correlated. Hazard curves are non-exceedance distributions, so the probabilities need to be continuously decreasing with stage and PGA. System response probabilities should be correlated with respect to loading to maintain their general shape. The same thing goes for consequence relationships. Although it is a simplification, we should correlate life loss between failure modes because how the public responds to a warning is likely going to be similar regardless of the failure mode. These first four items, what we are really doing is leveraging correlated sampling techniques to replicate the consistent percentile method. With regards to breach and non-breach life loss, assuming perfect correlation is a good practice if the mobilization rate is driving the estimates. The idea is for a given scenario, if people are going to mobilize at a high rate for a non-breach warning, they would also mobilize at a high rate for a breach warning and vice versa. If, however, warning issuance is the driving factor, then it is reasonable to assume no correlation since the warning issuance time for breach and non-breach are not related. In reality, breach and non-breach life loss will not be perfectly correlated or perfectly uncorrelated, but these are good places to start. In the short term, there's been some talk about building the ability to calculate correlations between scenarios into the MMC toolbox, but the long-term goal is to build that feature into LifeSim. Here are two examples of life loss tornado plots that show life loss correlation to parameter uncertainty. For the scenario on the left, warning issuance and other factors are driving the life loss. So we probably do not want to correlate breach and non-breach life loss. For the scenario on the right, mobilization rate is clearly driving the life loss. So we'd want to correlate breach and non-breach life loss. We'll talk more about tornado plots toward the end of this session. Circling back to the last full exercise we did, this slide shows how the CDF would change if we correlated distribution A and distribution B. The distributions were uncorrelated for the orange CDF and correlated for the blue CDF. To correlate the distributions in Excel, what you would do is use the same random number to sample distribution A and distribution B at a given iteration. That way, if it samples high for one, it will sample high for the other, and vice versa. As you can see from the plot, correlation mostly reduces the variance in the output distribution because the correlation basically eliminates the chance of sampling high from distribution A and low from distribution B, and also the chance of sampling low from distribution A and high from distribution B. Even though the range in the outcome is smaller, the mean and median will be comparable whether the distributions are correlated or not.